0900 hours. March 3rd, 1943. The Bismarck Sea. Major Ed Larner sits in the cockpit of his B-25 Mitchell bomber, staring down the barrel of a Japanese Asashio-class destroyer. The distance is closing at a combined speed of 300 miles per hour. The massive gray hull fills his entire windscreen. His altimeter reads just 50 feet above the whitecaps. Every instinct taught in Army flight school screams at him to pull back on the yoke, to climb, to trade speed for altitude, to get above the lethal envelope of the ship's anti-aircraft fire. Instead, Larner pushes the nose down. To the Japanese gunnery crews tracking him, this American looks insane. He is flying a lumbering medium bomber right into the teeth of their 127mm main batteries. It looks like a suicide run. But Larner isn't trying to die. He is exploiting a fatal geometric flaw in the Japanese Navy's defense systems. He knows that if he stays this low, he enters a ballistic dead zone, a blind spot where the enemy's heavy guns mechanically cannot depress fast enough to track him. He is betting his life on a theory that says the safest place to be is directly in front of the gun. But to understand how a medium bomber ended up dogfighting a destroyer at wave-top height, we have to go back to a humid jungle hangar in Brisbane, and a mad genius with a blowtorch who refused to listen to the Pentagon. That mad genius was necessary because, by late 1942, sanity was losing the war in the Pacific. For the first year of the New Guinea campaign, the United States Army Air Forces had attempted to fight a naval war using a doctrine written for the industrial heartland of Germany. The strategy was called high-altitude precision bombing, and on paper, it was flawless. The theory dictated that heavy bombers, like the B-17 Flying Fortress, would fly in tight formations at 10 to 20,000 feet, safely above the effective range of most anti-aircraft fire. Using the top-secret Norden bomb site, a computer so advanced and classified that pilots had to swear an oath to destroy it with a .45 caliber pistol. If they were shot down, they would drop patterns of heavy ordnance that could, theoretically, drop a pickle into a pickle barrel from 3 miles up. But the Southwest Pacific wasn't a pickle barrel. It was a dynamic, fluid chessboard of moving steel. And against the Imperial Japanese Navy, the flawless doctrine was failing with a catastrophic 3% hit rate. The problem wasn't the pilots, and it wasn't the bombs. It was the brutal, unforgiving mathematics of time and motion. Consider the geometry of the drop. When a bombardier in a B-17 at 10,000 feet releases a 500-pound bomb, that weapon is not a laser beam. It is a dumb object governed by gravity and terminal velocity. It takes approximately 37 seconds for that bomb to travel from the bomb bay to the ocean surface. 37 seconds is an eternity in naval combat. Down on the surface, Japanese destroyer captains had turned survival into an art form. They would stand on the bridge, binoculars trained on the American formation soaring high above the clouds. They watched for the specific moment the bomb bay doors yawned open. They waited for the glistening black dots to detach from the belly of the aircraft. And then, they simply turned the wheel. A Japanese destroyer, traveling at 30 knots, moves at roughly 50 feet per second. In the 37 seconds it took for the American bombs to fall, that ship could travel over 600 yards, 6 football fields in any direction. By the time the bomb actually slapped the water, the ship was simply no longer there. The ocean would erupt in towering geysers of white water, rocking the Japanese vessels but leaving them completely unharmed. The captains would then correct their course and continue steaming toward New Guinea, their cargo holds full of troops and ammunition destined to kill Americans. To the air crews of the 5th Air Force, it was an agonizing cycle of futility. They were flying 8-hour missions, burning thousands of gallons of aviation fuel, and risking interception by Zero fighters, all to make big splashes in the Bismarck Sea. They were fighting a war of near misses. And in 1943, a near miss didn't sink troop transports. This failure was driving Lieutenant General George Kenney, the commander of the 5th Air Force, to the brink of an aneurysm. Kenney was a short, aggressive, pugnacious leader who cared very little for the polite theories of the War Department back in Washington. Washington loved the B-17. It was the glamour girl of the Air Force, the flying fortress that was going to crush the Nazis. But Kenney knew a dirty secret. The B-17 was the wrong tool for the Pacific. It was too expensive. It required long concrete runways that didn't exist in the jungle. And against moving ships, it was statistically useless. Kenny looked at the reports piling up on his desk in Port Moresby. The Japanese were reinforcing their garrisons at Lae and Salamaua with thousands of fresh troops every month. If those convoys kept getting through, the Allies would be bogged down in the jungle for a decade. The high-altitude dogma wasn't just failing, it was costing lives. Every transport that the B-17 seconds missed meant another battalion of Japanese infantry digging into the muddy ridges of New Guinea, waiting to ambush Australian and American diggers. The definition of insanity is doing the same thing over and over and expecting a different result. The Pentagon wanted Kenny to keep flying high and tighten the formations. Kenny wanted to change the game entirely. He needed a way to take the 37-second gap out of the equation. He needed to eliminate the Japanese captain's ability to maneuver. He didn't want to drop bombs onto a ship from 3 miles up. He wanted to slam bombs into the side of a ship from point-blank range. But to do that, he couldn't use the heavy, lumbering B-17 seconds. He needed something faster, something more agile, something that could get down in the mud and brawl. He looked to his medium bomber squadrons, specifically the North American B-25 Mitchell. The B-25 was a solid, reliable twin-engine plane, but it had a glass nose designed for a bombardier to sit in and peer through a sight just like the B-17. It was built for level bombing from medium altitude. It had a few defensive machine guns to scare off fighters, but it lacked the forward-firing punch to suppress a destroyer's heavy guns. If you flew a standard B-25 at a ship at 50 feet, the glass nose offered zero protection. The Japanese gunners would chew the pilot and the bombardier to pieces before they ever got within range. The plane, as it came from the factory, was defenseless in a head-on fight. Kenny realized he didn't just need a new tactic, he needed a new animal. He needed a plane that didn't exist in any manual. He needed a commerce destroyer, a flying gun platform that could unleash such a volume of fire that the enemy gunners would be too terrified to lift their heads. But the engineers at North American Aviation said it couldn't be done. They said mounting heavy cannons in the nose would throw off the center of gravity. They said the recoil would pop the rivets and tear the airframe apart. They said the B-25 was a bomber, not a fighter. Kenny didn't care what the factory said. He had a secret weapon that wasn't in the inventory. He had Major Paul Gunn. Major Paul Pappy Gunn was not a man who fit neatly into a military dossier. In an Air Force obsessed with youth, procedure, and perfectly pressed uniforms, Gunn was a 43-year-old Arkansas roughneck with grease permanently etched into his fingerprints and a terrifying indifference to regulations. He had been a naval aviator in the 1,920 a commercial airline manager in the Philippines in the 30 and was now, technically, an engineering officer. But to the mechanics sweating in the jungle hangars of Australia, he was simply the wizard who could fix anything with a wrench and a curse word. Kenny didn't just value Gunn for his mechanical genius, he valued him for his rage. When the Japanese war machine rolled over the Philippines in 1941, Gunn had managed to escape in a Beechcraft, flying refugees out under fire. But he had left something behind. His wife, Polly, and their 4 children had been captured by the Japanese army. They were currently imprisoned in the Santo Tomas internment camp in Manila, living on starvation rations behind barbed wire. Gunn wasn't fighting for a flag, and he wasn't fighting for a pension. He was fighting to clear a path through the Pacific Ocean to get his family back. Every Japanese ship that stayed afloat was a physical obstacle between him and his children. This singular cold fury made him the perfect man to attempt the impossible, transforming the B-25 Mitchell from a high-altitude bomber into the world's first dedicated gunship. Gunn looked at the B-25 differently than the factory engineers did. To North American aviation, the B-25 was a precision instrument. The glass nose, or greenhouse, was essential for the bombardier to spot the target and align the northern sight. To Pappy Gunn, that glass nose was a waste of space. In the stifling heat of a hangar in Brisbane, Gunn laid out a plan that looked like madness. He proposed ripping out the bombardier's station entirely. No more crawlway, no more Norden bomb site, no more guys sitting in the front doing math. He wanted to plate over the glass nose with solid sheet metal and pack the front of the aircraft with artillery. Specifically, he wanted to install the Browning AN M2 50 caliber machine gun. The Modus, as the troops called it, was a weapon of terrifying power. It fired a thumb-sized slug at nearly 3,000 feet per second. It didn't just poke holes in things. It shattered engine blocks, shredded light armor, and liquefied human beings. A standard B-25 carried 1 or 2 of these for defense. Gunn wanted to mount 4 of them directly in the nose, fixed forward, controlled by a button on the pilot's control yoke. But he didn't stop there. He looked at the sides of the fuselage, right under the cockpit windows, and decided there was empty real estate. He fabricated external pods, blister packs, bolted to the skin of the aircraft, each housing another 2 machine guns. When he was finished drawing, the math was staggering. 4 guns in the nose, 4 in the cheek blisters. That was 8 forward-firing heavy machine guns. This concept, which Gunn dubbed the Commerce Destroyer, meant that when a pilot like Ed Larner pressed the trigger, the aircraft would unleash a stream of lead weighing 80 pounds per second. It would deliver more kinetic energy than a light tank. It was designed to do one thing: overwhelm the anti-aircraft crews on a Japanese destroyer before they could even aim their weapons. It was suppression through absolute devastation. The problem was, you couldn't just tape heavy artillery to an airframe and hope for the best. When word of Gunn's project reached the engineers at North American Aviation in California, they were horrified. They sent urgent cables to General Kenny, warning that the B-25 was not stressed for that kind of recoil. They argued that firing 8 50 calibers simultaneously would create a vibration so violent it would pop the rivets holding the aluminum skin together. They claimed the recoil force equivalent to nearly 4,000 pounds of backward thrust would stall the aircraft in midair. Basically, the factory told Kenny that Pappy Gunn was going to tear the wings off their airplanes. Gunn didn't send a cable back. He just kept welding. He scrounged the guns from wrecked P-40 fighters that had crashed in the jungle. He built the ammunition feeds out of scrap metal and desperation. He cannibalized solenoids from broken starters to build the firing mechanism. It was garage engineering at its finest, executed in 100-degree heat by men shirtless and covered in oil, modifying sophisticated aircraft with hammers and hacksaws. But as the prototype, Margaret, began to take shape in the hangar, a new, more insidious problem emerged. It wasn't the recoil, and it wasn't the rivets. It was simple physics. By adding nearly 1,000 pounds of guns, ammunition, and armor plate to the very front of the nose, Gunn had drastically shifted the aircraft's center of gravity forward. The B-25 was now nose-heavy, dangerously so. If a pilot tried to take off, the heavy nose would refuse to lift. Or worse, if he chopped the throttle to land, the nose would drop like a stone, flipping the bomber onto its back and killing the crew instantly. Gunn had built the ultimate weapon, but he had also broken the fundamental laws of aerodynamics required to fly it. He had created a monster that was itching to kill its own pilot before it ever saw a Japanese ship. To make the Commerce Destroyer fly, he would have to hack the aircraft's balance just as aggressively as he had hacked its armament. The easy part, building the guns, was over. Now, he had to make the brick fly. To make that nose-heavy monster airworthy, Gunn had to perform radical surgery on the aircraft's internal organs. He crawled into the fuselage and started ripping out everything that wasn't bolted down. He disconnected the heavy radio transmitters from the navigator's compartment behind the cockpit and dragged them, wires trailing like guts, all the way to the tail of the aircraft. It was a crude, backyard solution to a complex aerodynamic problem. By shifting hundreds of pounds of electronics to the rear, Gunn acted as a human fulcrum, forcibly counterbalancing the 1,000 pounds of steel he'd welded to the nose. When he ran the calculations on his slide rule, the center of gravity drifted back into the safe zone. Barely. But the real test wasn't sitting on the tarmac. It was pulling the trigger. Gunn took the prototype, Margaret, up for her maiden combat trial over the Coral Sea. He lined up on a drifting piece of wreckage, leveled the wings, and squeezed the button on the control yoke. The effect was apocalyptic. All 8 50 caliber machine guns fired at once. The cockpit instantly filled with the acrid, biting smoke of burning cordite. The airframe didn't just vibrate, it shuddered violently, as if the plane had flown into a solid wall. The recoil knocked nearly 20 miles per hour off the aircraft's airspeed in seconds. The noise was deafening, a continuous jackhammer roar that drowned out the engines. But the wings stayed on, the rivets held, and down in the water, the target simply evaporated under a concentrated storm of lead. Gunn landed with a grin. He had proven the Commerce Destroyer could fight. Now, General Kenny needed to prove it could sink a fleet. While Gunn was reinventing the airplane, another officer, Major Bill Ben, was reinventing the bomb. Ben was Kenny's aide and a quiet intellectual who had spent months obsessing over the physics of water entry. He knew that guns alone, no matter how powerful, couldn't sink a 6,000-ton troop transport. The machine guns were the jab designed to blind and stun the opponent. The bomb was the knockout cross. But dropping bombs from 50 feet presented a terrifying problem: physics. If a pilot dropped a standard bomb from that height, one of two things would happen. If the angle was too steep, the bomb would dive deep underwater and explode uselessly in the mud. If the angle was too shallow, the bomb would hit the surface and ricochet wildly, cartwheeling over the ship like a skipped stone gone wrong. Ben realized that sinking a ship required hitting a geometric sweet spot, a precise corridor of speed, altitude, and release point that looked impossible on paper. He took a squadron of B-25 seconds out to a rusting shipwreck on a reef near Port Moresby, the SS Pruth. This battered hulk became the most bombed ship in the Pacific. Day after day, Ben and his pilots flew runs against the rusted iron corpse, treating the ocean like a physics lab. They discovered that to make a 500-pound bomb behave like a flat stone on a pond, the aircraft had to be flying between 200 and 250 miles per hour. The altitude had to be exactly 60 to 100 feet, and the bomb had to be released roughly 300 yards from the target. When executed perfectly, the bomb would hit the water, skip once or twice to bleed off kinetic energy, and then slam squarely into the side of the ship. But this solution created a new, immediate danger: self-destruction. A standard bomb fuse is set to detonate on impact. If a B-25 pilot released a bomb at 300 yards while flying at 200 miles per hour, he would be directly over the target when the bomb exploded. The blast wave from a 500-pound warhead would shred the low-flying bomber instantly, swatting it out of the sky like a fly. The pilot would essentially be blowing himself up to sink the enemy. The solution came from a crate of Australian naval supplies. Kenny's ordnance teams borrowed long-delay fuses typically used for depth charges. They set the fuses for a 4 to 5 second delay. This tiny mechanical timer changed everything. It meant the bomb would strike the ship's hull, punch through the steel plating, and actually sit inside the cargo hold or sink just below the keel for 5 agonizing seconds before detonating. That 5-second window gave the B-25 pilot just enough time to pull back on the yoke, scream over the ship's masts, and clear the blast radius. It transformed a suicide run into a survivable tactic. By late February 1943, the pieces of the puzzle had finally snapped together. Pappy Gunn had built the gunship that could suppress the defensive fire. Bill Ben had cracked the physics of the skip bomb, and Ed Larner's 90th Bomb Squadron had spent weeks practicing on the poor, battered SS Pruth until they could put a bomb through a porthole at 200 miles per hour. But Washington remained unconvinced. The official manuals still explicitly forbade low-level attacks on heavily armed warships. The high-altitude generals argued that flying a medium bomber into the point-blank range of a destroyer's main batteries was reckless disregard for government property. They predicted 50% casualty rates. They called it a waste of planes and pilots. General Kenny ignored them. He didn't care about the manual. He cared about the reconnaissance photos landing on his desk. Japanese signal intelligence had just confirmed the nightmare scenario. A massive convoy, Operation 81, had departed Rabaul. 8 destroyers, 8 massive troop transports, 7,000 soldiers. They were steaming under the cover of a storm front, heading directly for the Leh garrison. The laboratory phase was over. The Pruth wasn't shooting back. The Japanese Navy would. The impossible experiment was about to meet the reality of total war. That reality arrived at 9:50 hours on March 2nd, when the heavy tropical storm front protecting the Japanese convoy finally dissolved. Below the breaking clouds, the Bismarck Sea was calm, too calm. The 16 ships of Operation 81 were exposed, steaming in 2 long columns toward the Huon Gulf. To the Japanese commanders on the bridge of the destroyer Shirayuki, the clearing weather was a concern, but not a catastrophe. They had their own air cover, dozens of Zero fighters patrolling the ceiling above them, and their ships were bristling with anti-aircraft guns specifically calibrated to shred American bombers at high altitude. They were ready for the B-17 seconds. They were not ready for the symphony of violence General Kenny had orchestrated to play out at deck level. This wasn't a raid. It was a perfectly timed execution. Kenny knew that sending the B-25 seconds in alone, even with their new guns, was a gamble. So he designed a tactical hammer and anvil. The B B-25 seconds were the hammer, destined to deliver the killing blow. But first, he needed an anvil to hold the enemy down and break their defenses. That anvil was the Royal Australian Air Force. Leading the charge was No. 30 Squadron of the RAAF, flying the Bristol Beaufighter. The Beaufighter was a brute of a plane, heavy and fast, but it possessed a unique mechanical trait that made it terrifying. Its Hercules engines used sleeve valves rather than standard poppet valves. This design quirk made the engines incredibly quiet at low RPM. The Japanese infantry had already given the plane a grim nickname, the Whispering Death. The Australian pilots dropped to 50 feet, barely skimming the wave tops, and approached the convoy from the beam. Because of their silent engines and the curvature of the earth, the Japanese radar and lookouts didn't detect them until they were less than a mile out. By the time the destroyer captain shouted for hard rudder, the Australians were already firing. The Beaufighter carried 4 20mm cannons in the nose and 6 machine guns in the wings. When 13 of them opened fire simultaneously on the lead destroyers, the effect was not like an air raid, it was like a broadside from a battleship. The 20mm explosive shells didn't just bounce off the steel hulls. They raked the decks, shredding the unprotected anti-aircraft crews and shattering the delicate glass optics of the gun directors. On the Japanese bridges, officers were thrown into chaos. Smoke obscured their vision, and the deafening roar of cannon impacts drowned out orders. The defensive perimeter of the convoy, usually a disciplined wall of flak, collapsed into a frantic, uncoordinated response. Gun crews were forced to take cover or die, and in that precise moment of chaos while the Japanese eyes were fixed on the Australians, the hammer dropped. Major Ed Larner and the 90th Bomb Squadron roared in right behind the Beaufighters. They didn't have the silent element of surprise. They had the terrifying roar of Wright Cyclone engines running at maximum manifold pressure. Larner lined up his B-25 on the lead transport. He was flying so low that the prop wash from his engines kicked up a twin trail of spray on the ocean surface behind him. This was the moment the Commerce destroyer modification was built for. At 1,000 yards, Larner squeezed the trigger on his yoke. The 8 forward-firing, 50 calibers erupted. The difference between the Australian 20mm cannons and the American 50 cals was subtle but crucial. The cannons were explosive, creating shock and damage. The 50 cals were kinetic buzzsaws. The solid slugs punched through the thin steel of the transport's bridge, turning the wheelhouse into a slaughterhouse. They perforated the steam lines, sending blinding white jets of high-pressure steam across the decks. The Japanese gunners who had survived the Australian pass now faced a wall of lead so dense it was physically impossible to stand up and man their weapons. The defensive fire from the ship, which should have been a curtain of steel, withered away to a few sporadic bursts. Larner held the dive. The ship grew larger. 800 yards, 600 yards, 400 yards. The psychological urge to pull up was screaming in his brain. At this range, a single lucky shot from a Japanese rifle could kill him. But the physics of the skip bomb demanded perfection. He had to wait for the geometry to align. At exactly 300 yards, point-blank range in aviation terms, Larner thumbed the bomb release. The 500-pound bomb detached from the belly. It didn't fall. It traveled forward, carrying the momentum of the aircraft. It hit the water at a shallow angle, kicking up a small splash, and then, defying the weight of steel and explosives, it skipped. It leaped 10 feet into the air, clearing the anti-torpedo nets, and slammed squarely into the side of the transport amidships. Because of the velocity, the bomb didn't just detonate against the hull. It punched through the half-inch steel plating like a bullet through cardboard. It smashed through the bulkheads and came to rest deep inside the crowded cargo hold, surrounded by crates of ammunition and drums of aviation fuel. Larner hauled back on the yoke. The B-25 groaned under the G-force as it leaped over the transport's masts, clearing the rigging by mere feet. Inside the ship, the Australian delay fuse ticked down. 1, 2, 3, 4. The explosion broke the transport's back. A column of water, smoke, and debris erupted 300 feet into the air, dwarfing the sinking vessel. The shockwave was so powerful that the B-25 seconds flying behind Larner felt their aircraft lurch as the air itself was compressed by the blast. This was the validation of Pappy Gunn's madness. The Commerce destroyer worked. The skip bombing worked. And as Larner banked his squadron around for a second pass, He saw the ocean littered with burning ships. The stalemate was broken. The massacre had begun. The massacre did not stop with the lead transport. It spread down the Japanese column like a contagion of fire. Within minutes, the orderly formation of Operation 81 had disintegrated into a chaotic graveyard of burning steel. Major Larner's 90th Bomb Squadron, now joined by the 89th and 90th Attack Squadrons, circled the convoy in a predatory loop. They were no longer flying like bomber pilots. They were flying like fighter aces, banking hard at wave-top height, engines screaming, hunting for anything that was still floating. This was the moment the Ballistic Dead Zone theory ceased to be a theory and became a shield of invincibility. As the B-25 seconds roared in for their subsequent passes, the Japanese destroyer captains frantically ordered their main batteries to fire. But the physics were against them. The American bombers were coming in so low, literally looking up at the destroyer bridges, that the heavy 127mm guns couldn't depress their barrels far enough to acquire a target. The shells screamed harmlessly over the cockpits of the B-25 seconds, exploding thousands of yards away in the open ocean. The Japanese were bringing knives to a gunfight, and Pappy Gunn had given the Americans a machine gun. The volume of fire generated by the commerce destroyers was rewriting the rules of naval engagement. A single B-25 strafer, unleashing all 8 forward guns, was pumping out over 100 rounds of armor-piercing incendiary ammunition every second. When a Japanese gun crew on a destroyer attempted to man their 25mm autocannons, they weren't just engaging an aircraft. They were staring down a concentrated stream of lead that shredded steel splinter shields and vaporized human bodies. The suppression was absolute. American pilots reported seeing Japanese sailors diving overboard before the bombs were even released. The terror of the strafing run was more potent than the fear of the ocean. By 15 hours, less than 30 minutes after the first Beaufighter attack, the Battle of the Bismarck Sea had effectively ended as a contest and begun as a demolition. 7 of the 8 transport ships were sinking or burning furiously. The destroyers, Shirayuki, Arashio, and Tokitsukaze, were crippled, drifting dead in the water with their bridges destroyed and their decks awash in blood. The remaining destroyers broke formation, fleeing north at flank speed, abandoning the slow transports to their fate. But the destruction wasn't over. The commerce destroyer had done its job too well. Thousands of Japanese soldiers and sailors were now in the water. They clung to lifeboats, rafts, and floating debris. Under the old rules of warfare, the rules of the 19th century, this would be the moment the shooting stopped. The enemy was defeated. The ships were sunk. But this was 1943. The Pacific War was not a gentleman's conflict. It was a war of annihilation. General Kenny had issued a standing order. Destruction of the convoy must be complete. Intelligence estimated that even without their ships, these thousands of troops could still swim to the nearby coast or be rescued by submarines. If they reached the shore of New Guinea, they would be rearmed and thrown into the jungle to kill American and Australian troops. So the order went out to the B-25 crews and the prowling American PT boats that arrived to mop up. Nothing reaches lay. The narrative shifts here from technical brilliance to the grim, industrial brutality of total war. The B-25 seconds dropped their flaps and slowed to stall speed, making low passes over the debris fields. They weren't bombing ships anymore. They were strafing lifeboats. The PT boats moved through the wreckage, their twin, 50 calibers sweeping the water. It was a slaughter, a grim necessity in the eyes of the commanders, a war crime in the eyes of the enemy, and a haunting memory for the men who pulled the triggers. But militarily, it was the final variable in Kenny's equation. Of the nearly 7,000 Japanese troops who departed Rabaul, fewer than 800 would survive to see active duty. An entire division of the Imperial Japanese Army had been erased from the order of battle in a single morning. And the cost? The Japanese anti-aircraft fire, which the Pentagon had predicted would decimate the low-flying squadrons, managed to shoot down only 2 bombers. Major Ed Larner brought his squadron home with perforated wings and shattered windscreens, but they came home. The B-25 seconds had flown into the heart of a prepared naval defense, violated every safety protocol in the manual, and achieved a kill ratio that was statistically absurd. They had sunk 12 ships for the loss of 2 planes. As the mechanics at Port Moresby swarmed over the returning aircraft, patching bullet holes and refilling the empty ammunition trays, the mood wasn't jubilation. It was a cold, professional satisfaction. The experiment was over. The argument was settled. The impossible modification had just won the most decisive air-sea battle of the entire war. Pappy Gunn's Frankenstein monster hadn't just worked, it had just rendered the Japanese Navy's entire resupply strategy obsolete. That obsolescence was total. The Japanese High Command looked at the reports from the Bismarck Sea reports, detailing the annihilation of 8 destroyers and 8 transports in under an hour, and realized they had lost control of the ocean. They never attempted to send a large convoy to New Guinea again. For the remainder of the campaign, the Imperial Japanese Navy was reduced to sneaking supplies into Lae and Salamaua using submarines or small wooden barges under the cover of darkness. It wasn't enough. The garrisons withered. Soldiers who had conquered Southeast Asia were reduced to farming sweet potatoes in the jungle to survive. The commerce destroyer didn't just sink ships, it strangled an entire army. Back in the United States, the engineers at North American Aviation, the same men who had warned General Kenny that Pappy Gunn's modifications would rip the wings off their aircraft, were forced to confront an embarrassing reality. A mechanic in a jungle shed with a welding torch had outdesigned the finest aeronautical minds in California. Rather than fight the future, North American Aviation adopted it. They took Gunn's crude blueprints and standardized them. The factory lines in Kansas City and Inglewood stopped producing glass-nosed bombers and started churning out factory-built gunships. The result was the B-25G and the B-25H. The factory engineers didn't just match Gunn's ferocity, they escalated it. If 8 machine guns were good, they reasoned, a field artillery piece was better. They installed a massive 75mm M4 cannon, a weapon designed for a Sherman tank, into the nose of the B-25. It was a weapon so powerful that when fired, the pilot felt like he had hit a brick wall in midair. Alongside it, they packed up to 14 and 50 caliber machine guns. The B-25 had completed its metamorphosis. It was no longer a medium bomber, it was a flying destroyer. This evolution revealed a fundamental truth about the Battle of the Bismarck Sea, one that often gets lost in the retelling. You have been told that this was a story about a suicide run. You have been told that Major Larner and his men were daredevils who threw caution to the wind. That is a lie. The skip bombing attack wasn't a suicide run. It was a math problem. And Pappy Gunn had solved it. The narrative of suicidal bravery is comforting because it makes war feel heroic. But the reality of the Bismarck Sea was far colder and far more impressive. It was an exercise in calculated, asymmetrical violence. Bravery is flying into a fair fight and winning. Genius is engineering the fight so that it is completely unfair before you even take off. When Larner flew at those destroyers, he wasn't gambling. He knew the geometry of the Japanese guns better than the Japanese gunners did. He knew the ballistic properties of his skip bombs. He knew that his forward firepower would suppress the enemy's ability to aim. He didn't win because he had more courage. He won because he had superior physics. In warfare, fair is a failure. You want unfair. You want to be the hammer striking the anvil. The legacy of that unfair advantage didn't end in 1943. The concept born in Pappy Gunn's sweltering hangar, the idea of a side-firing, heavy weapons platform dominating the ground, became the DNA for a new lineage of aircraft. Decades later, in the jungles of Vietnam, the U.S. Air Force would remember the lessons of the Bismarck Sea. They would take a cargo plane, the C-47, and mount miniguns in its windows, creating Spooky. That evolved into the AC-130 Spectre, a flying battleship that circles targets, raining down 105mm howitzer shells. Every time an AC-130 loiters over a battlefield, suppressing enemy movement with overwhelming firepower, it is paying homage to the commerce destroyer. The lineage is direct. The philosophy is identical: overwhelming suppression, low-altitude dominance, and the mechanical ingenuity to turn a transport or a bomber into a predator. But in March 1943, the men of the 5th Air Force couldn't see that far into the future. They only knew that the immediate threat was gone. The Bismarck Sea was silent, save for the wreckage drifting in the current. The architects of this victory, however, would not have long to savor it. The Pacific War had a voracious appetite for its heroes, and the men who broke the Japanese supply lines were flying on borrowed time. That debt was collected barely a month later. Major Ed Larner, the man who had flown down the throat of the Japanese Navy and emerged without a scratch, did not die in combat. He wasn't shot down by a Zero or a destroyer. On April 30th, 1943, while flying a routine administrative flight, His aircraft suffered a mechanical failure and slammed into a hillside. He was 32 years old. The pilot, who had mastered the most dangerous tactic in the Pacific, was claimed by the mundane friction of military aviation. But the architect, Pappy Gunn, flew on. Gunn continued his one-man war against the laws of aeronautics and the Japanese Empire. He modified A-20 Havocs, he tweaked P-38 Lightnings, and he flew combat missions well past the age when most men were rotated to desk jobs. He was driven by that singular burning need to reach Manila. And in February 1945, he did. When the 1st Cavalry Division liberated the Santo Tomas internment camp, Pappy Gunn was there. He walked through the gates and found Polly and his 4 children. They were skeletal, starving, and traumatized. But they were alive. The mad mechanic had hacked the B-25, revolutionized air warfare, and cleared the Bismarck Sea, all to pave the road that led him back to his family. The Battle of the Bismarck Sea remains the ultimate vindication of heretical innovation. It proved that when you are facing an entrenched, superior enemy, following the manual is a death sentence. The 5th Air Force didn't win because they followed orders. They won because they rewrote the physics of the engagement. They realized that the safest place to be was in the dead zone, and the only way to survive the fire was to become the fire. If this deep dive into the engineering of victory gave you a new perspective on the Pacific War, make sure to hit that like button. It helps us bypass the algorithm and get these stories to the people who need to hear them. Subscribe to the channel and turn on notifications so you don't miss a single briefing. But while Pappy Gunn's B-25 seconds were ruling the waves, the skies above the Pacific held another secret weapon, a fighter plane that pilots called the fork-tailed devil. It was plagued by a mysterious aerodynamic phenomenon called compressibility that froze the controls in a dive, killing dozens of test pilots. But once engineers solved the riddle of the Mach Tuck, it became the only aircraft capable of hunting down the man who planned the Pearl Harbor attack. We will declassify the technical secrets of the P-38 Lightning in our next video.